Welcome on next part of the video tutorials on how to use our BazerCam. Okay, in this video tutorial I will try to focus on the laser machines and different settings in the program for them. Okay, I loaded some clip art into a program, into a background, and I will use a laser plasma cutter. I want this detail to be cut out from the material using a laser or plasma machine. And the difference is between the wire and the laser. The wire cannot be retracted, I said before, from the material. The laser could be just switch off and move to another position and switch on again. And this first option will just do that. That means it will just regenerate the edges of the images, and then it will just generate a G-code to go around these edges and cut this detail out. We have the same edge detection level. We have something like a laser focal size, and that's for other options, but here we can just leave it like this. And we have some additional options. This one is switch off, and we have an option for a laser. That means that's a power, how it will be switched on. That means G-code M3 and M5. M3 switching on the laser or the whatever is connected to the output, and M5 it's switching it off. We can use MO6 code. For example, if you're using some kind of a different controller, like a 3D printer controller or something similar to that, you might want to use this code because you're connecting your laser PWM output to the output of the fan, and then just changing the fan, the PWM signal, you making the laser going brighter or darker. That means this one will use a standard MO6 code, and you can just generate something custom. When you switch custom, you can just put some G code here, and it will be passed into a program, and then it will generate, for example, M48S, and there is a dollar sign, and this dollar sign means the power of the PWM. Yeah, it just replaced the power of the PWM. The same is for power off. We have M48S0. That means switch off the power on some pin. Okay, let's go with MO6 and click done. Just click background to matrix, the same as in a wire cutter. Detect the edges. Okay, we have done that. We can use a fast mode because we didn't want to edit that. Go and just click laser to path, and that's done instantly, very quickly, without any higher calculation, because the laser could be just moved to another place and switch on, switch off. That means there is no need of just calculating all the lines are connected correctly. There is continuity and things like that. You just clicking save G code, or you can just click send by the USB and send it directly to the controller. Okay, that means the plasma laser cutter we have covered. Let's do something more difficult. Okay, I will load the same image. Okay, and now instead of cutting the detail out, that means making the cut on the edges, we want this picture be engraved by the laser, has been cut out from the material, but where the black, we want that totally blacked out, whereas white, of course, the laser should be switched off. We can use the option fast engraver, and that will just do that. And in a fast engraver, we have a minimum and a maximum detection. That means minimum, we can play with that. We can just lower down minimum to some gray, but if the picture is just black and white, half is okay. I mean, that's a half of the scale. Minimum is 0, maximum is at 255. Okay, now the laser focal size is important because that will determine how many lines we need to generate to just make that black, for example. Diagonal horizontal, when the diagonal is switched on, the algorithm will generate the code to move both axes in the same speed. That means it will just cut 45 degrees lines. That means the both axes will be used in the same way. they will just go. When we switch that off, of course, there will be just one axis working like X, and then just Y will be just dropping a very low. When the double scan is switched on, we will generate a cross path. That means if we have a diagonal and the double scan is switched off, the line will be just one direction. When we switch a double scan, there will be a line just crossing. That means first time the algorithm will just drove all the lines in one direction. Then when it's finished, it will start generating the lines in a different direction just to create a cross path. Okay, invert PWM, it's just simply inverting the power of the laser. That means instead of a full power on the black, it will go zero power, and the full power will go on the white. Okay, speed to power is a bit experimental and is developed for a laser engraver image to raster, but is here as well. It simply replaced the laser power. The laser is still switch on, switch off by the G code, like a MO6 or M3 M5, yeah. But instead of generating a PWM for the laser, it's changing the speed of the movement. For example, on the white, because when the laser moving pretty fast on material, even when it's switched on with some full power, for example, when we move that very fast, it will not make any mark, or will just make a very faint mark. When it's slowed down, then it have a more time to transfer the laser energy and make the change in material. That means this option is just speed to power, and instead of a PWM, we're using the speed, and the G0 0 and speed when the laser is switched off is the same, but minimum speed is when the laser is on the black, and the maximum speed is when the laser is on the white. Yeah, that means with that speed we'll move over the white, and with 25 millimeters per minute it will move over the black. Yeah, that depends of course from the power of the laser. You can play with that, because for example, if you have a very powerful laser, you can use something like 1000 millimeters per minute on a black, and for example some very fast movement like 60,000 millimeters per minute on a dark, but I don't think so any machine can do that. Let's go for something like 3000 maybe. Okay, right, we switch off the speed to power. We have almost everything done. Laser focal size is 0.3 millimeter. What we're doing, we're just clicking background to matrix, and in this moment it didn't generate the edges, it just generates some kind of the mesh. And the mesh is just a representation, because it's much thinner than this one, where you can see on the zoom out. We can zoom in, and then we will see really how many lines there is. Okay, and yeah, as you see, because the diagonal was switched on, the lines are diagonal. When I just switch off a diagonal and regenerate the same matrix, the lines are now horizontal. Okay, and the same thing when you switch off double scan. That's a one line scan. That's up to you, but anyway, that's how the program is generated. There is no need of a regeneration anything. You just clicking save or send to USB, and the program is sent directly to the controller or save as a G-code somewhere in the computer. We can click info, and we see there is 11,374 lines in this project. Okay, that's a simple engraving. That means laser switch off, laser switch on. Let's do something more difficult. Okay, just got to click that. Z imaging. Let's make that smaller, like 200 by the 200 millimeters. Okay. And now we're switching the image to raster. That will simply means the program will generate the power of the laser when the black is switched off, and the color will determine the power of the laser, and it will generate the same kind of the double scan lines. And we have a parameters. Minimum detection is a black. We can just play with that. We can just raise it to avoid some defects on the image if there is any, but this one is a pretty good. And the maximum is a white. For example, there is no white, but we can just play it down. I believe that would be some kind of the gray, close to 200. And that's it. The same options are here: diagonal, double scan, invert, or speed to power. Like I said, this one should work pretty well in kind of the pictures like that. When you're using some kind of a small power laser, we can try to generate this image on a kind of the material, like some kind of the, I don't know, wood or whatever. And then when it's the black, the laser will be switched on. When it's the white, laser will be switched off, switch on, or we can just invert it. Of course, we can do that other way, inverting the image. We can go to a background and just ask it to negative, and that will generate us exactly negative of the picture. And now the algorithm will just take the picture which is in the background to regenerate. That means where is the white laser will be switch on, and where is the black laser will be switch off. Okay. Right, we have that settings done. Okay, let's see how the algorithm go. Okay, now we can see the program slow it down a little bit, because in this project we have a 250,000 of the lines. But you can see all of them. I don't know how the YouTube will show that, but they are pretty fine, and they are generated as they should be. That means the laser just going from the edge and start just moving, and then it switch on gradually, rising the power to a maximum power, and then it switch off again, going through the lines. And that's how the laser raster to image to raster works. Okay. All right, one more thing on the end. I just noticed in some settings of the laser, or when I editing, when I switch on the pointer showing incorrectly on the program, because the program which I'm using to record the desktop, it's not recording correctly the pointer. It's showing it much bigger, and it's showing the pointer in an offset to the point where it is. I don't know why it's doing that, but that the pointer is much smaller than is on the video, and the pointer is exactly on the point where the cross center showing, not somewhere offsetted to the edge. But that's only one thing what I noticed when I check the videos which I made before. Okay. All right. Thank you very much. Next video will be on the mills, how to use the same program to generate the G-code for a 3-axis mill.